First law, inertia. Objects are fundamentally lazy. If it's at rest, it stays at rest. If it's moving, it keeps moving at a constant velocity unless an external unbalanced force kicks it out of its comfort zone. Think of your body jolting forward when a car suddenly brakes. Second law, F equals ma. Force equals mass times acceleration. More force means more acceleration. More mass, less acceleration. Simple math. Third law, action-reaction. Forces always come in pairs. If object A pushes object B pushes back on object A with the exact same force, but in the opposite direction. Just like a rocket pushing gas downward to launch upward. Part 2. The core challenge, the mathematical setup. The setup. Now, let's tackle something brilliant, Newton's law conversion. How do we mathematically prove the law of inertia using action and reaction? Imagine a block, body A, resting on the ground. By Newton's third law, the Earth pulls the block down with its weight, and the Earth pushes back up on the block with a normal reaction force. Because they act on different bodies, we write this equal and opposite pair as. Part 3. The step-by-step conversion. Step 2. The net force. If no other outside forces are interfering, the net resultant force acting strictly on our block is the sum of the normal reaction and its weight, since they are equal and opposite. Step 3. Bringing in the second law. Now, let's plug this into the definition of acceleration from the second law. If and our net force is 0, then. The insight. What does a zero acceleration actually mean? It means there is absolutely no change in velocity. The object is either perfectly at rest, or it's cruising along at a constant velocity. Part 4. The mind-blowing conclusion. The reveal. Look at that final state. An object stays at rest or maintains uniform straight-line velocity because its net force is 0. Sound familiar? That is literally the definition of Newton's first law. The takeaway: by taking the interaction mechanics of the law and applying the mathematical machinery of we smoothly derive the law. They aren't isolated rules. They are different perspectives of the exact same universe. Part 5. Outro and engagement. Call to action. Mind blown? If this step-by-step breakdown made physics click for you, smash that like button, subscribe for more conceptual deep dives, and drop a comment below on which physics derivation we should tackle next. Create community postscript options to promote this upcoming video asset.